Complex numbers are not a trick. They are a way to let numbers move in two directions instead of one. The real line gives left and right. Add an imaginary direction, and every number becomes a point or an arrow on a plane. A complex number has two parts. We write z equals a plus bi. The number A moves horizontally along the real axis. The number b moves vertically along the imaginary axis. So 3 plus 2, I simply means go 3 steps right, then 2 steps up. The symbol I is the new unit direction. 1 points right, I points up. Multiplying by I turns an arrow 90 degrees counterclockwise. Do it twice, and the arrow points left. That is why I squared equals -1. Addition is the easiest part. To add two complex numbers, add their arrows head to tail. Real parts, add horizontally. Imaginary parts, add vertically. Nothing mysterious happens. 2 plus I, plus 1 plus 2i, lands at 3 plus 3i. Multiplication is where complex numbers become powerful. A complex number has a length and a direction. Multiplying by another complex number does two things at once. It stretches by that length, and it rotates by that direction. Complex multiplication is scaling plus rotation. That is why the polar form is so useful. Instead of saying horizontal part and vertical part, we say distance r and angle theta. The same point can be written as r times cosine theta plus I sine theta. Rectangular form is good for adding. Polar form is good for multiplying. Euler's formula is the bridge. e to the I theta equals cosine theta plus I sine theta. As theta changes, this number walks around the unit circle. The exponential is not leaving the plane. It is drawing rotation in the plane. Now powers and roots become visible. Squaring doubles the angle. Cubing triples it. And the nth roots of 1 are just n equally spaced points on a unit circle. Complex numbers turn algebra into geometry.